Okay, so hey guys, welcome back. And today we will be dealing with this majority element. Uh, and I'll just stop it right here and I'll just go through my blogger post. As you know that I always do this. I put it in a blog and I do it from there. So yeah, this is what the preview will look like. And before anything, let's start. So, see, it's very simple for us that it was a normal array given to us, and we have to find out the the number in the array that is repeating more than the n by 3 times. That means the length by 3 times. So, if that is a case, you can do it very easily, going through setting up counters and all those things, sorting it out using your data structures. But how here the main note was that algorithm should run in linear time and in O of one space. So if you have some time, I will not take much of you. I'll just give you my approach and then I'll tell you what happened because otherwise you will be waiting for it and you might not be interested on that. So the first solution I did was very like lame solution. I can say I just put a hash map there. I counted the number of occurrence and if the number of occurrence was greater than nums by 3 means here I am going to the entry set and if the value is greater than nums dot length by 3 basically n by 3 and I'm just putting it in the list and I'm returning it into the list and then I submitted the solution. It was accepted. Wow, wow, congratulations. After that, I thought what else I can do. Then I realized, okay, I can do this. I can sort the array at first, and then I can simply, without anything, I can just use it with the help of a count variable. So I did that. I sorted the array and I did the initial check. If the num length is greater than zero, just return the empty list. And then later I found out that okay, I'm iterating through the loop. I am just iterating till the second last element because I am checking the first and the second element in a particular iteration. And then I am also checking if the elements are same, just count plus plus. And if the elements are not same, and then check because we have already did a sorting. So then check if the count has been exceeded the nums dot length by 3. If it is, then just add it and set the count, means reset the count to 1. Or else again reset the count to 1, but don't add anything to the list. After that, we need to see for the last element, right? Because we are putting 1 and all, we need to see for the last element. If the last element, for the last element, the count is still greater than that nums dot length by 3. If it's still greater than, if the count is still there, it's not to 1, still there, then we can add the last element also. And this was it. It was also pretty much successful. It was around 60-50% of people were in my zone, and then it was around 60-70. Again, the space complexity was there. But later I found out that arrays dot sort may not be working on O of n, O of 1 all the time. It can be going to O of n also. So then I gave up. I gave up and I found out looking something and I found this Boyers-Morey majority vote algorithm. So here I found it out and I see that what it is, and I found out that okay, we can think of it like this. If anything is given as that nums dot length, basically the array length by 3, that means any element which should exceed should be 2, because if it's by 3, that means if it's 4, it cannot be 4, right? Because those two elements are exceeding the values of that divided by, suppose there is 10 and or 9, basically you are doing 9 by 3, right? So there can be 4 and 5 or 4 and 4. There cannot be 3, 3 and 3 because it's not greater than 3. Right, so this is what it is, and this is where it clicked me that because it's n by 3, and it not doesn't click me actually. I saw the solution, but then I realized okay, we can do it like this: n by 3, and then count 1 equal to 0, count 2 equal to 0. Candidate will be -1, so that we know they are all positive integers, or we can take integer dot min also if you want, and then we just iterate through the loop and we go step by step. We first check if the candidate 1 has any value. If it has, then we will be having a counter 1 for the same candidate. we'll increment it. Then we'll see if the candidate 1 is not having value, we also check for candidate 2 is having value. If its value is there, then we increment it again. Or if other than that, again we are seeing that their candidate 2 is not having value and candidate 1 is not having value, then we put count, because the first time we go, I'll just let me just give you this particular piece of code in Paint. I hope you love Paint, because I have just invested 4K rupees, not dollars, sorry, in this. So, okay, yeah. So let's start what I can say. Okay. So let me before it copy something. What I'll copy is I'll copy this particular input. Okay, and I'll paste it for you. So if we see for the first titration, right? Okay, again it's brush only. I need a pen. This is a pen, right? Yeah. So for I equals to 0, what will happen? For I equal to 0, what will happen? The let us say I1 for the number. Okay, it will be 0. I2 will be 0, basically minus 1. And then C1 will go and we'll see C1. Okay, so there is I1, I2 has no value still now. So C1 will be going to 1. Then here we'll put I1 as uh, that number. It will be 1. Then we go for then we go for 1. Here we see the I1 is 1. Okay, the I2 here is 0, and we see C1 is 1. See, I1 is 1, so we will put C1 also 1 here. I2 is 0, C1 is 1, and C2 is 0. So now what we'll do, we will put the I1 will have 1 and C1 will have 2. Okay, now coming to 2, what we will see, if we will see that the I1 is 1 here and I2 is 0 still, because still we are coming, still it's 1, right? This one is still 1. So still I1 is I2 will be 0, count is 2 and it is 0. Now I1 will be put to 1, C1 will be put to 3. Now we'll go to the third one. Here we'll say I1 is 1, I2 is 0, it is 3 and 0. Now we will see, because this one is already passed, we see C2 is 0. C2 will be 0. So C2 will be set to 1 and I2 will be set to 2. Then we will go for 4. It's very simple now. It's 1, 3, sorry, not 3, it's 3, okay. 3, 3, 1, C2 is equals to 2, I2 is equals to 3. Then we go for 5, okay, it's 1, 3, then it is here, it's 3 and 2. But now we will see that the at I at 5, right? It is 2. So that means it doesn't belongs to any of them. So what we will do? We will do C2 minus minus C1 minus minus. Okay, now 6 will come up. It's 1, 2, 3, 1. C2 minus minus C1 minus minus. Then we'll go for 7. It is now 1, 1, 0, 0. So here we will again go on the approach, because C2 is empty. So we will do C2 plus 1 and we will put I2 as that particular I value, that is called 2. So now we have what we have. We have I1 pay 1 and I2 pay 2, and then we will put another loop where we will count for these two, and we will do C1 and C2 0 before that. And once this is done, we will get the counts of C1 and from C1 and C2 for I1 and I2. We'll see if C1 has greater than n by 3 and C2 has greater than n by 3, and particular thing we will be including in the list. And I think it's pretty simple, right? So this is what we have done here. If you can see here that if candidate 1 is I, then count plus plus. If 2 is I, then count plus plus. If 1 is 0 because already it will go inside after this. 1 is 0, candidate 1 is equal to I, 1 it's greater than that. Yeah, so let me go down slowly in this particular loop. It's if candidate 1 equals to I. It is I, no, because first iteration 2 is also not equals to. So we see 1 is equal to 0. Yeah, good. We put it here. We put count 1 is equal to 1. Go down till 1 is there. Then for 3 we will come here. We'll increment. Then for two times we will be decrementing it. So count 1 will have one value left, but count 2 will be 0. So here for count 2, the candidate 2 will be 2 here. Even if it's jumbled up, you will still be able to see that particular value. Don't worry. So now after going after basically what I said, the array is jumbled up, it's not sorted. Still you will be able to pass through this particular loop, and you will be able to get the maximum number of occurrence for two array elements. Okay. Then we will be putting count 1 and count 2 again to 0, because we will be seeing what are the exact counts for those elements which we got in candidate 1 and candidate 2, I1 and I2, which I told you in the example. Then we will just see if the count 1 is greater than n by 3, count 2 is greater than n by 3, count 1 make it's candidate 1, and count 2 is candidate 2, and we'll return. So that is okay. And I think you can stop the video right here. But what I learned from this, as a if you are a beginner or something, first I did was I checked what does O of one space call, and I don't know why. Okay, let me just go back, and where is a view for this? Cancel, update, back. I want to view it. Hmm. Okay, so I will view it. Oh, it should open in the next tab. So I checked what is O of one complexity, and I went through here. He said that it's basically the pointers, and O of one can be considered as pointers. It's completely different between space complexity, and there are two types of ways which was explained here, that allocate. But if you can go through this particular link, it will be okay. And then what I did was, okay, that's good enough. What I can do now? So what I can do now is I did the second one where I see array dot sort. But then I got a mind in my mind that is the array dot sort having a good time complexity and a space complexity? So here I got to know that the implementation it's done in an array, and I saw everywhere. So it said that the SI is empty, get, set, iterator, list iterator operation runs in constant time. The add operation runs in amortized constant time, that is adding an n elements acquire 0 of n time. So sometimes array dot sort will not work, and it is for array list. I'm sorry, actually, I think I forgot. I think it is for array list. I checked for array dot sort. Somehow it's not there in this link. So let me just give you array dot sort weight complexity. Yeah, this one I searched. Yeah, and here I found out that yes, it will be doing this O of n square maybe for the worst case, and O of n time. So it was not O of n uh, for that basis. So that's what I'm saying. Like this will be the likelihood was omega of one. I am not. I think it's omega or something else, which means another year the space complex usage is not O of one, right? So this one I thought that okay. I think I cannot say my second statement was good. So then I went to Boye More majority voting as algorithm. So here it's a completely different criteria which we I got it that the algorithm is finding the majority of a sequence of elements using linear time and constant space. It is what is named after and all those. Simplest form was that algorithm finds a majority element if there is one. That means the element should be occurring more than half of the input. Okay, so that will be always be one. So if it's half, it's one. If it's three, it's two. That's how I get it. And this is the script description. Local variable we can have its local variable a sequence and a counter. Counter initially is zero. It is then process the elements on sequence one at a time, and all those things here. And this is what it observes that it uses O of one. And if there is a majority element, the correctness was also there. There was some references So that's how I did my part in understanding this whole application. Sorry for that whole code. And I hope you also learned a bit. And I think this is how we have to do. If we are facing any issue, we have to just go and check it out. And I hope you liked it. I think I have spoken a lot of information, and this blog is not particularly available as of now. I mean, if I know you can just copy and see it, but yeah, okay, too much information. Bye bye.